Hi everyone, my name is Ryan Booz. I'm a Postgres advocate with Redgate Software. And as I've said in the previous two videos so far, I'm starting to work through the advent of code about a week late using SQL, as I have seen some of the folks I follow in the Postgres community talking about doing this. It really intrigued me, trying to solve these puzzles just with Postgres and the functions that are provided through SQL. So the attempt is hopefully as we go day to day, can we solve these problems without creating functions, custom functions using something like PL/PGSQL, that would give us more logical kind of operations, things of that nature. So that's the goal. I don't know how far we'll get before I might have to dive into PL/PGSQL. And my solutions, again, they're always going to be different between different people, how you approach it. Anytime I get stuck, if I really can't solve a problem, I will probably go to a few of these other folks that I know are doing advent of code with Postgres, and I'll always be sure to give them credit because my goal is not a leaderboard. My goal is to learn and figure out how to process all this really unique data to solve these problems. So day 3, let's flip over to day 3 and talk about what PL/PGSQL, the puzzle is for day 3 and how we might solve it in SQL. So for day 3, we got a data file that looked like this. There are, I believe, 300. Again, we'll check how many rows, but I think there's 300 rows here. And it's a bunch of letters, all lowercase or uppercase, so a total of, what is that? My brain is not picking it out. 52 total letters, I believe. So somewhere in there. And the idea here is that every row represents a pack, a rucksack from an elf. And the pack has 2 compartments. And this is a listing. Every letter represents an item in the rucksack. And it's actually 2 compartments worth equal. So if you split the string in half, the first half of the string, each letter represents an item in compartment 1. And the second half, each letter represents an item in compartment 2. That's the goal. So we need to take these strings, we need to split it apart, do some of that work. And then the first puzzle was, now once you determine the items that are in each compartment, there's one item found in both compartments. And so they have some level of priority, and the priority is determined where they fall within the sequence of all lowercase letters, 1 to 26, all uppercase letters, which would be 27 to 52, right? So what that total, you find the item, let's say in this case, this is what they're talking about here. Let's say the item is a P, then it would be worth 16. If the item is a capital L, it would be worth 38, and so forth. You find that common item for every row, you add up the values, and that becomes the answer to the first question. So what is the sum of the priorities of all those items that appear in both compartments? So let's look at how I looked at solving this. So as I've said in the other 2 videos, I created a table to import that data into, has the ID column in case I need it, and then it has the contents, so that's string. That's the contents of the data. In total, there were 300. So you can see down here, there's 300. I will get my little drawler here. So it's 300 rows in that file. And this is what the file looks like. I mean, in SQL, it shouldn't surprise you, I think, from that text file. There's one column with an ID and the other column with the text. So the first thing I did is got a little iteration, but I knew I had to split the string apart into 2 total strings, and then I would have to do something with those, with the values. Now, the nice thing is I knew that each set should have the same number of characters. So that gave me a couple things to choose from. So the first thing I did is, for the rucksack, that's the text, that's all the contents of the rucksack. The easiest way for me in SQL is to use a substring. So in SQL, in Postgres, it is substring, the thing that you want the substring of. Now, Postgres is 1-based, so we want to say from the first string until halfway through the string, that's portion 1. And then the second substring is the contents, and we want to start, again, since it's 1-based, not at the length, but the length plus 1, half of the length, but half of the length plus 1. When I do that, you'll see that I get 2 strings and they're equally separated. Great. So now I have that, and you'll see I do this all the time because it makes life easy when we're trying to kind of build up a query. And so I have that CTE that returns this data. Now the next CTE, so this is the next part of the common table that I'm building. I said, hey, contents one, remember it's two parts of the rucksack. So contents one is the first part of the rucksack. Contents two is the second part. And so I simply I'm taking the first, remember sack one is the first part of the rucksack, sack two is the second part. So I'm taking that string, I'm splitting it apart on null, which means every character becomes a column, and I'm adding the ID to it. So the row, in this case, let me look at this one right here. What I should get out of that is an ID of 1 repeated for every letter of that first string. So in this case, I don't know, maybe say there's 10 or 13 letters here. I'm not going to count them. I would get 13 rows. All of them would have ID 1, but every letter would have its own row. So it kind of gives me a little table that I can do something with later. If you're thinking about SQL, maybe you'll see where I'm going. Again, that's how I decided to do it. So let me just show you what that looks like really quickly. Just so we're on the same page, select star from contents 1. Capital doesn't matter. That was just, that's just dbeaver doing that for me. So this is what it looks like, right? And you can see the numbers start changing. There's variable lengths. Some have 10 characters, some have 15 characters. That's not really the point that matters here. All right, let me go and get rid of that. So I do the same thing for contents 2. You would see the exact same kind of table. So now I have 2 tables. And then I happen to have just been doing some work with strings. I was trying to answer some questions maybe a week ago. And I was going back through the string functions in the Postgres documentation. And I happen to remember the position. Again, it's something I don't use all the time. I was like, oh yeah, the position function. I bet that's going to be helpful here. And so the string, remember the position of the element is determined by this string here. So, a capital A is going to be worth, in this case, 27 points because it's the 27th letter in this string. 26 American character, US characters, English characters. That's what I meant. And then the next, repeated again in capitals. So what I have to do is select, I just simply did a join. So the deal is I have 2 tables. They both have the same ID, but they have a different letter in the second column. When I do an inner join on both columns, so both the ID column and the letter column, I happen to call it S1 and S2. This is what I did up top there. Inner join will only return the rows that are a complete match of the join. So if there's only one item that matches, I'm only going to get those rows back. Now the problem is, even with an inner join, if there are multiple on one side, it's going to join to the multiple side on the other side. So I'll still get multiple rows. So to build this up really quickly, let me take this just so we can see what comes out of this. And it should work. Let's see if it does. It does. So you'll see that, for instance, guess ID 98, there were one of the columns had, in this case, 3 Bs, and the second column had maybe just 1, but it gets a join 3 times. So ultimately out of this, and I didn't order by, I should have, just so you can see that, sorry for the confusion, order by 1, there we go. So in this case, guess 2, one of the sides had 2 capital Vs, therefore I got 2 rows. So really what I want is the distinct of that. So I can add a distinct around it. That's what this second inner query gives me. All right, so now if let's say I did that, and I'm going to get, now I have for every guess, here's the 1 row and the 1 letter that matters. And so now I can iterate over those rows. Every letter is going to go row by row. For every letter, I'm going to find the position in this string that has a value, and I'm simply summing them up as I go. And I get the answer of 8,053, which was the answer for puzzle 1. Now, a slightly more, easier to follow answer. I could have maybe formatted this a little bit better. Maybe that would have made this a little bit more clear. Another alternative instead would be to do this intersect. All right, so I did think about that later. In fact, I think I solved it. That's right, this was day 2. I solved it, and I went to see one of the gentlemen. I don't remember who it was. I saw that he did the intersect. I'm like, that is so much easier. Again, it's just fun to learn. And so if I were to replace this with the distinct, this intersect, which says, so I have the same rows in the same types. That's the one thing you have to know for intersect or accept. It has to be the same number of columns in the same type for each column. And then we'll go row by row. And in this case, intersect says only return rows that are a match on all columns where they intersect. And so again, that would give me duplicates. And so intersect distinct does the same thing as doing that distinct. So this is just a little bit easier. Oops, I must have. Oh, okay, that's right. I had to, I ended up doing it differently down here, reusing that because it ended up being a little bit easier. So the column items does not exist because I called these something different. So that's right. I would have to, in this case, my apologies. I'd have to say item here instead, and now I'd get the same answer. So it does also have to have the same column names, but the types also have to match. Okay, so that would be a potential easier way of doing that. Now let me go to guess 2. So number 2 was now figure out within a group of 3. So for every 3 rows, assume that these are a group of elves. This is the next group of elves. So within a group of elves, they all have one common item and only one common item between them. So now I had to take not just, I don't have to split the string apart anymore. I just have to look at the full string, split them up into groups first, and then, each elf, I have to identify elf 1, 2, and 3 within each group. So I can say, hey, which item is within a group and distinct between, there's at least one in each of the elves' sacks or rucksacks. And so how did we do that? So the first thing I did is I knew I had to at least get a group. And so actually I didn't do this first. I did just this. So I'll move this comma down here so it's a little bit easier. So I at least knew I had that ID column. Remember I said I'm going to do that almost every time because it might come in handy. So if I do the ID, and again, at first I think I first did this, just kind of playing really quickly to see what would that give me. All right, so because it's going to create an integer, it's going to round, it's basically going to round up. And so, the first 2, I'm basically off by 1. I need those first 3 rows to be the thing. And so, to be that first group. And so if I go -1, I know that row ID 3 -1 would be 2. They'll all get that 0. So at least they'll all be together. All right. And then I did need to know the group, and I did try a couple things. I honestly forget how I ended up here. I thought I actually maybe tried mod first for the elf group. And so I played around, ended up here with mod. And so this allows me to get not just the group, but within each row, right? So I'm taking what's the remainder of, this value when the mod, the division is by 3, what's the remainder? So that gets me a different value for every row, either elf 1, 2, or 3, or in this case 0, 1, or 2, in every group. Okay, so now I have things broken up. So now I have to do, so I can just pull that out. I get the exact same data. Great, now I have that. What can I do with that? Well, that string to table seemed like something that was useful before. And so I can just take the same, same basic approach. I'm going to get the ID, or I'm going to get all of the items in each elf's rucksack. It's going to have with it the elf group, and which elf within that group all of these items belong to. And so if I were to take select star from contents, right, this is what we end up with. So very similar to that first puzzle, except in this case, I'm not comparing 2 halves of a string. I just took the whole string for every elf, turned it into a table. And so now we get, item SF, capital D, for group 1, elf 1. I know it's elf 0, but again, it's just easier. And then I get the second elf, all of their items within the whole rucksack. And then we get really close. So again, after I had realized the intersect as probably the easier way to do this, that seemed a lot easier. So I could say, hey, the item and the group where the contents are for ELF1, so get just all of them. So I'm basically taking this whole big thing, and now I'm getting a smaller table for ELF1 for in every group, ELF0, but ELF1 in every group, get all of their items. Intersect that with ELF2 in every group, all their items, and the third ELF in their items. Intersect distinct just like before, and we end up with, in fact, let me just do this quickly so you can see what it is. I'll do this. Star, see if that works for me. So, and then I could have ordered by ELF group, but I won't just for the sake of it. But you can see that all of these are just for each group, what's the one item that was common among all of those tables. Really pretty straight, easy way to do that. And when you take those priorities, you get 2,425, and that is a good solution for day 3 of Advent of Code using SQL. And then I think, yeah, so these were other, I was doing some maybe copy down below. I thought maybe I had a third example down here, but I don't. So again, taking some text, processing it into some kind of set so that we can use the functions within SQL and get both of our answers. Hope that was fun and helpful, and we'll head over to day 4. Take care.